Hello, ladies and gentlemen. Today we are talking about Algebra Chapter 2, Lesson 11, or 2.11, Simplifying Expressions. Today is a pretty simple day. What we're going to be doing is taking variables, coefficients, terms, the distributive property, and exponents, and putting them all together to make very simple and succinct equations. So let's get started. Let's say we have our equation that looks like this. It is 2x plus 4y minus x. Now you notice that I like to write these terms in different colors. I like to write like terms in the same color. As you can tell, we don't have any like terms here. We have three different colors. The 2x literally translates into x plus x. There are literally two x's. The 4y literally translates into 4 y's. Oh, but we do. I'm sorry. And this is why we go over this. The negative x is technically 1 negative x minus an x plus a negative x. So we do have like terms. So if I'm trying to simplify this, first I look for my like terms, which I have found there are two like terms, the 2x and the negative x. Because I can say, what is x plus a negative x? Well, it's the same idea, right? If you had 1 plus 1 plus a negative 1, you would get 1 plus 1 is 2. 2 plus negative 1 is the same thing as saying 2 minus 1, which is 2 minus 1, 1. Or another way to think of this is you have two x's and you take away 1x, right? 2x minus x. That's just going to be 1x, right? This negative x gets rid of one of those x's, so you're left with a singular x. Either way, you could also do it where I rearrange and I go 2x minus x, so I have all the like terms next to each other, plus 4y. And so I say, what is 2x minus 1x? Because there's an invisible 1 in front of that. 2 minus 1 is 1, so 1x plus 4y. And 1x really translates into x, so you've got x plus 4y. And there's nothing more we can do, because you cannot combine x and y, right? In the same way you couldn't combine apples and bananas, you can't combine x and y's, therefore it ends like that. Let's try another one. If I had 5 plus 2 multiplied by x plus 3, how would I solve this? How would I simplify it? Well, if I'm going to simplify this, I'm going to start at the very beginning, a good place to start. I'm going to use the distributive property because I see right away, excuse me, I see right away that this 2 can be multiplied to this x and to this 3. So I'm going to get 2 times x using the distributive property. I'm going to get my plus sign, and then I'm going to get 2 times 3. And if I rewrite everything, it'd be nice and clean. And then I can solve using PEMDAS. Do I have parentheses? Sure enough, the 2 times the 3. That's 6. And I just clean up the whole problem step by step. All right, do I have exponents? No. Multiplication? Already did that with the 2 times 3. Division, I don't see any. Now addition. Yes, I have addition. I've got this 6 here, and I've got this 5. I can rearrange this because it's a normal 5 plus 6. And then I have the 2x on this side because the x tells me that I cannot combine the 2x with anything else here, right? 5 plus 6 is 11. 11 plus 2x. Because this is really x plus x. And x plus 11 is the same thing as saying 11 plus x twice, or 2 x's. So there is your final answer. I'll go ahead and pause the video if you need to go over that again and to write that into your book. I'm just going to keep on going. Let's try another one. Let's simplify this problem here. I have a negative 6x plus a 4 by itself, parentheses, 5 minus x. So when I'm trying to simplify these, the first thing I'm going to look for is anywhere I can use distributive property. And right away, I see I can do it with the 4 times the 5 minus x. So I'm going to have a 4 times 5 right here. And then I'm going to have a 4, drop the negative, forgot the negative, sorry. Drop the negative, and then I'm going to have 4 times x, which is going to give me 4x. And I'm going to have my negative 6 out here in the front because nothing happened to it. Now all I do is simply use PEMDAS. Parentheses, 4 times 5. 4 times 5 is 20. Rewrite the problem. You don't have to rewrite the problem every time. I just like doing it because it keeps everything nice and in order. I'm going to change the color to a green. Okay. Now I notice that I have this 4x here and this 6x. They have the exact same variables, the x. It's literally 6x's and 4x's. So negative 6x minus 4x, let's rearrange it so it's in order. Negative 6x, you take the sign with the term, so negative 4x, and then take the sign with the term plus 20. And all I did was I rearranged it using the commutative property, right? So negative 6x minus 4x, negative 6 minus 4 is the same thing as negative 10. So I'm going to have negative 10x's plus 20. And that's it. I cannot combine the 10 and the 20 because it's not really a 10. This is just telling you how many x's there are. And how many x's are? How many x's are there? There are 10 negative x's. I'm not going to write them all out, but you get the idea. And how many ones are there? There are 21. So it just ends right there. There's nothing more we can do. It has been simplified as far as we can go. All right, let's try one with exponents. Let's say I had 2xy squared. Ooh, now we're getting a little harder. Plus 8 minus, oh, I have to use xy squared plus 4. Now this one's a little trickier. And the only reason it's trickier is because what we have, as you've noticed, is we have this xy squared. So some people think that it is x plus y squared, or it's some type of new variable. You just treat it like a normal variable. What this really says is, look, this is xy squared, which is really x times y squared, which is really x times y times y. And how many sets of those do you have? Well, you have 2x times y squared, right? So you have 2 of these. You've got x times y times y. You have it twice. Plus x times y times y. That's how you got the 2x times y's times y, or 2xy squared, which is the same thing as saying x times y squared, or 1, negative 1 x times y times y. That's why what we're about to do is we're about to take away 2 minus 1, which would give us just 1xy squared, right? That's how we're going to do that. So in reality, what we can do is we can rearrange this original problem so that's a little bit easier to manage. So I'm going to rewrite it 2 times xy squared. I'm going to bring over this whole term, negative xy squared. There's an invisible 1 in front of that if there's no number already placed. Then I'll put this positive 8 here, and this positive 4 I'm going to leave here. So now I'm going to combine like terms. 2 minus 1xy squared is just 1xy squared. So this has been taken care of. And then 8 plus 4 is the same thing as saying 12. So my final product is going to be 1 times xy squared. I don't really need the 1 there, so it's just going to be xy squared plus 12. And that's it, because I cannot combine the xy squared plus the 12. They don't have like terms. Shall we try another one? All right, let's go with a nice easy one. Here we go. If I have 4 times x minus 3 plus 5. Well, I need to simplify this, so I'm going to try to use the distributive property to do this 4x times this negative 3. So I'm going to get 4 multiplied by x. That's their first one. Drop the negative. Then in the next one, it's going to be 4 times 3. And all of that's going to be plus 5. Use PEMDAS, parentheses first. This is going to be a 4x situation. 4 times x, or 4 x's. X 4 times. Minus 4 times 3 is 12. Plus 5. And so now we realize that we have 4x by itself. There's no other x's, so nothing's going to happen to it. But now we have a negative 12 plus a 5 right here, right? Negative 12 plus 5 is negative 7, right? So 4x minus 7. And there's nothing else you can do with that because you can't combine the x's and the 7. So that's where it ends, 4x minus 7. Let's try another one. Remember, you can pause this video at any time if you need extra time or help. Let's try 8m. I've got 8 m's. And I'm subtracting 1n. I'm going to draw that in a different color for sure. And then I'm going to subtract a 3m, a set of 3m's. And then I'm going to add 12 n's. So what's going to happen? Well, if I were you, I would rearrange this so that all the like terms are next to each other. So I notice I have a negative 3m here. I'm going to put that next to my 8m. So I'm going to drop this 8m. I'm going to take this negative 3m and rearrange it, put it right next to each other. Then I'm going to put the 12n first because it's larger. And then I'm going to put this negative n over here. So now it's a little easier to deal with. If you had 8 mangoes and you subtracted 3 mangoes, how many mangoes would you have left? 1, 2, 3, 4, 5, 6, 7, 8. Well, let me make it m's. 1, 2, 3, 4, 5, 6, 7, 8. Take away 3. 1, 2, 3. How many do you have left? 1, 2, 3, 4, 5. 8 minus 3 is 5 mangoes, or 5m. Over here, if I had 12 ninjas, and I took away one ninja because that's just one N, right? One ninja. How many ninjas would I have left? Well, you'd have 11 ninjas left. You'd have 5 mangoes plus 11 ninjas. And you can't combine ninjas and mangoes because those aren't the same thing. So therefore, you're done. Let's try one more. Let's go with, oh, here's a good one. It's got a negative in it. We've got negative 2 minus x minus 8. So what we do here is we realize, oh, there's a -1 in front of that, right? And so you can say, all right, -1 using the distributive property times 2 is -1 times 2. Then you could say -1 times negative x. A negative times a negative is a positive, so it's going to be positive x. And then -8, nothing happens to it because it's not in the parentheses, so it's not affected. It just drops. -1 times 2 is -2 plus x minus 8. Well, I've got a -2 here and an 8, so I can rearrange this. So it's -2. Then I'll bring over the -8 because they're just numbers or constants plus x. -2 minus 8 is -10. It becomes smaller. -10 plus x is just -10 plus x. There's nothing else you can do to it. Now, if you wanted to make it cleaner, what you could do is x minus 10 and just rearrange them if you'd like. Up to you. Both answers are the same though. -10 plus x and x minus 10 are the exact same thing. Let's do one more. Yeah, let's do one more just to be safe. Let's say I had, this is a very good one. 5b times, 5b plus 2 times b minus 2. What do we think happens here? Well, I see I have a parentheses and a variable and a number on the outside, so I can do 2 times b, which is going to be 2b. And then I could do 2 times -2, which is -4. And then I could just rewrite this 5b in the front here. I include the addition symbol because it didn't go anywhere, nothing happened to it. So now I've got 5b plus 2b minus 4. My like terms are the b's. 5 bananas plus 2 bananas is a total of 7 bananas. And then nothing happened to the 4. So it's 7 bananas minus 4. I cannot take 4 away from 7 bananas because I need it to be 4 bananas. And since we don't have anything behind it, we can't assume that's bananas. It's just a 4. So there we go. 7b minus 4 is your answer. Ladies and gentlemen, I hope this helped you, clarified some things. If not, please let me know and we can go over it together. All right, we will see you in the next video.